Hey all, today I want to demo something that I was just working on, which is basically mimicking something really close to the ChatGPT new long-term memory feature. So what I was working on here, this is going to be just a demo basically. But if I'm building let's say a cooking application on the left, which is going to learn a lot about me and my family and our cooking habits, um, if I simulate that conversation over here, on the right side, I just want to do this for demo purposes, but I'm going to be extracting information from the conversation as I have it about things like allergies, food likes, family attributes, and we'll see those kind of populating as I have a conversation. So I'll demo walking through this application. I won't go through how I built the actual application, but I do just wanted to touch on the memory feature today. So I'll share code if you're interested. You can play along in GitHub with how that the memory agent works. Then I'll also just walk through some of the theory or the approach that I took to why I went with this method that I went with today. So quickly, the basics here are I want to have these long-term memories because if I come in to do a new meal planning session, it needs to know information about me. So here it's got that fact that my daughter is allergic to dairy. Are there any other things that I need to know? And here I might say, my wife and I don't eat meat. And so it'll have this conversation. In the background, the memory agent is going to be listening to the messages that I send and storing things as dislikes or likes or attributes, or it's going to update something if it's wrong. Is there anything else? No other restrictions. So we'll submit that. How many meals do you plan per week? So we eat six, I'll say dinners at home. We live in Austin, Texas. And so we also have a garden that we like to cook from. So let's see if it can now extract kind of a bunch of pieces of information from a longer message like that. So it's summarizing all of that because it has some of that kind of like conversational message or history, but we also want this long-term message or long-term memory. So yeah, it's got an attribute, has a garden, live in Austin, Texas, eat six dinners at home. So now it's kind of assembling this whole picture of me. Um, so here we've got this whole conversation and quickly, oh man, this something, I just kind of stole this from Gemini because I got really tired of all the UI and chat interfaces kind of populating up from the bottom. And you'd kind of, especially if you're doing code or something and you're kind of requesting it, it's just kind of flying by and you're trying to copy and paste it. So I love that they just kind of every message, give me a new message, just kind of wipes the slate, populates from the top down. If you're interested in something, you can grab it as it keeps going, especially as it has really long responses. So that was just a UI thing that I liked because I'm really tired of all the ones just kind of filling up and going. And then every new line is just kind of bumping it up. So I definitely stole that because I thought that was cool. Anywho, how do I actually build this thing? Um, Let me talk quickly. So MemGPT, this is a really cool project and research paper that came out a while ago, probably, I don't know, 6 months or something like that. So I definitely looked to that as some of the inspiration after I kind of started down a really simple implementation. They've got a great paper here that really explains their process, but they were basically doing something very similar, but way more robust, which is how do you combine long-term memory and short-term memory? How do you have a whole queue of messages that you would, as it gets too long, kind of condenses? And so basically, how do you pack as much information into a small context window as possible? The way they approached it, they've always got the system instructions that go through. They have some of these kind of long-term working context. Um, I believe that's long-term. I don't know. I read through this one, but won't explain it probably perfectly correctly. So this would be some of those kind of long-term memories and family attributes. And then they also have a queue of messages that are happening. So that whole conversation would be in the queue. And when the queue hits a certain point, they're going to now condense and say, all right, after 10 messages, let's condense that into kind of one long-term memory. And that kind of fuchsia section down here is now long-term memory. You'll clear the queue out, begin a new conversation. So this queue will always kind of contain the full length of a few messages that happened and then condensed long-term message history and then some relevant context for the message or for that current conversation that's going to be pulled out of uh, a combination of some kind of archival storage and recall storage. So they're kind of condensing all of those things into that one conversational chain, which is really cool. But today we want to do, or I just want to do something a little bit different. I also want a simpler implementation. I also want to have control over it, and I want to just build it myself to see how I would actually go about this process. So here's the diagram that I have. Imagine I'm having a conversation here between a user and an assistant, and I'm talking about my daughter has a dairy allergy. Great. Anything else? I don't eat meat. All right, we got those two pieces of information. I love breakfast tacos, obviously. Um, so that's kind of a conversation. If I come back another time and I say, what cake should I bake? I want it to remember that my daughter has a dairy allergy. So how do we accomplish that? Well, we need to kind of remember some of these long-term kind of pertinent information and store them somewhere. So each one of these has some, maybe 0 to n number of different pieces of information that I do want to save. So there's kind of two things I have going on here. One is just the conversational agent that's kind of powering this conversation. The other one is going to be listening in on the conversation and extracting information to the long-term memories. So my meal planning agent, it has a normal prompt, but imagine it also has this additional bit of context, which is the long-term memories that can be pulled in. So it knows about the dairy allergy and don't eat meat, the breakfast tacos. It has all that information that it can pull in from this memory database. It's got some sort of running message log because it needs to have the context of what's going on here, and then the most recent user request. So that's actually what's kind of just outputting this next answer. Um, but that's not actually now creating the memories. So how we create the memories is I made a separate memory agent. So every time I fire off one of these messages, it's triggering this. It's also going to trigger this, and you could power those a lot of different ways. I could be just saving those in some sort of a message database that kind of takes these actions or whatnot, but this is a simple implementation, so I'm just kind of managing the message history right now in the user session. So that's not really persisting long term, but a better implementation probably would be storing all of those messages somehow. So today I'm just really focusing on this memory agent, and the way I set it up, this is kind of expensive computation to run every single time, and so there's a lot of ways you could optimize that. But today I really just kind of broke it up into two steps. One is kind of a run through some low cost model of just look at the system message or the message that was just sent, compare it to our recent memory or the memories that we do have. Does it have anything new or not? And so an inexpensive or kind of a less premier model is going to do a pretty good job of identifying whether or not it does have new context. So I run it through just that. I call it the little memory sentinel first, just to say, does this message have anything new? And so this is going to be really inexpensive and fast to run. If it does, I send it to a memory manager, which is going to be today just powered by GPT-4 because I don't have time to kind of go through a whole like fine tuning or figure out something better. But GPT-4, this is just a side note, but I think it's incredible to just prototype with GPT-4. If you can do it with GPT-4, it's going to be more expensive, but you'll probably find a way in the future. If you need to scale up and optimize, there's going to be a lot of ways to do it, but you can just get to that prototype so rapidly that I basically always just kind of build the prototype here to make sure it does work. And then as you're hitting scale later, then you can figure out cost optimization and speed optimization, all those things. But just to make sure it does work, I just dive straight in and do that. So this is where my actual memory manager is. And this one has a much longer prompt. It's a very similar setup basically, but it's just a longer, like how are you actually kind of looking at these different pieces of information? And then it just goes to one tool caller. And that tool caller gets all the information if it needs to create memory, update, delete, what the memory is, what attributes it has, or what category it is, etc. So it's kind of, extracting all of that. And this is now, use whatever database tools you're going to do, but this is how I'm actually now creating, updating, deleting my memories is through a tool caller. And so this is now going to update the memory, and now we have in the database this kind of long-term structured information that's being used. So that's the approach that I took. It's pretty simple of just having these two agents kind of running in parallel. Um, and I will walk through the code now for just kind of how that works. So here I've shared this. This will be in GitHub, so you can have access to it as well. And it's going to walk or completely mimic what I just demoed. So we've got the memory sentinel. This is kind of agent number 1. It's got a pretty long prompt here, which really just tells it to, we're interested in these 4 bits of information. And this is what's going to be kind of, depending on the context of your application, this will be really customized, well, the types of information that you're looking to store. So ChatGPT is used this wide, huge use case where kind of everything is relevant. For this kind of cooking use case, there's really just a couple of pieces of information that I actually really want to pay attention to. I don't care if last week you had too many tacos and you don't want to eat tacos this week. That's not something that needs to persist. The fact that you like tacos, that is something that is interesting. So I give it a little bit of that information and I just kind of analyze it, see if it has anything worth recording, only respond with true or false. So it's getting a really simple, squish that together, give it a less impressive model, but still have some reasoning power. And that's all we're going to do with the Sentinel. The next one, the memory manager, this is the one that has kind of the tool set up. So, and I guess, wow, I didn't even demo or say this. This is all going to be we're using LangChain and LangGraph to run this. So down here to memory manager, I'm setting up a tool for this agent. So this is a custom tool that I'm doing. This is modifying knowledge. So it's going to run this modify knowledge function. This is really just stubbed out here for the demo, but you're going to need to write something for actually kind of creating, updating, or deleting your piece of information. This function is just kind of a router to send it to any one of those. It's the knowledge modifier, and what we're passing into it is this add knowledge information. So I want that string of knowledge that I'm saving. So in the other application here, it'd be this daughter's allergic to dairy. Then we have, depending on if we're updating or deleting information, I also wanted to know what the old piece of information was. So instead of passing an ID, which kind of seemed to throw it off a little bit, and you probably could optimize it to get the IDs to work, I was just passing in the full old string. So it'd say find this old string and delete it, or find this old string and we're going to update it to this new knowledge string. So that's why there's kind of a knowledge that's going to be the new piece of information and the old piece of information possibly. Might just be none if it's, this one's optional if we're adding some new piece of information. Then we're going to have one of the categories, which is going to be the allergy, like, dislike attribute, and the action. Are we creating, updating, or deleting? So this is what the memory agent is going to be doing, the actual kind of taking the information and figuring out what we're going to do with it. So that's the tool it has. We're going to bundle up those tools and pass it down into this brain here. So this has a more in-depth system prompt. Again, we're going to be telling it a lot of the similar things, just in a little bit more detail. So we're tracking allergies, likes, dislikes, attributes about the family. The new steps are now going to analyze the most recent human message. We're only really looking at the most recent message. Compare this to the knowledge you already have about a person. Determine if it's new knowledge, update to old knowledge that needs to change, or should just delete something that's incorrect. And then now we pass in our memories. Here's the recent information we have. I give it a little encouragement at the end. And now squish it all into a brain again. So we've got the system message, all the messages that are being passed back and forth. I give it the GPT-4 because I need it to now do a lot of reasoning and the parallel tool calling. And we're going to create our runnable here and bind the tools to it, which we do through the convert to OpenAI function. And it's attaching the tools that we walked through up here, just that one tool here. So now that's basically it. It's got those 2 different kind of, LLM runnables. So it's not really a complicated agent here, and LangGraph is just easy to run now. It's just easy to control these things. So it's not doing a lot of reasoning and figuring out its own different loops, but still easy to set it up this way. So this is going to be how the graph is set up. So we've got a state now that's got messages, memories, and we're just tracking if it does contain information. I'll talk through the nodes in a second, but first we'll talk through the graph. So we've got the 3 different nodes here are the Sentinel. So that is, hey, does this have any information? We've got the knowledge master. We know this has information, so how do we want to save it? And then we have actions once we know, hey, you're updating this, you're deleting this, and you're creating this. These are the actions that we need to do the tool calling. So for our edges, we're always starting with Sentinel. We always want to run that one first and determine if anything needs to actually happen. Otherwise, it can bail. And so that's the conditional edges. When Sentinel runs, if it contains information, we're going to move on to the knowledge master. Otherwise, we're done. Once the knowledge master runs, there's going to be a should continue function that determines were any tools called. If they were, we're going to call them. Otherwise, we're done. And then finally, once we call the tools, we're done. So all these things just kind of they bail the moment that this is not an agent that's going to run for a long period of time. It's really just going to run through a couple of steps and just kind of drop off when it needs to. So that's the only thing here that's going on. We've got a couple of those nodes. If we want to look at the code, this is going to be really quick. You can kind of run through this yourself, but none of these are doing anything that complicated. It's just putting the sentinels being called with the messages, and we're setting a contains information of true or false, or yes or no. This determines should continue just if there were any tool calls in the last message that was sent. When we're calling knowledge master, we're just pulling in the messages and memories and passing them through and invoking it. And then finally the tool calling. So this is going to run through for every tool call required. It's going to actually do the tool invocation. We're going to append that tool message to our message log and just run through each of those tool calls. And honestly, even appending it to the message log isn't really necessary because we're not returning any of this to the user. It's just kind of happening in the backlog, and those tools that are being called are updating the database. So this message is, you don't even have to do this kind of tracking here, but it's curious just if you want to for the logging. So if we actually run this, and let's say we have a message here that has a bunch of information in it. There's 6 people in my family, my wife doesn't eat meat, and my youngest daughter is allergic to dairy. So when we run this and actually just kind of invoke that whole app, we'll give it a memory run name so we can track it in LangGraph. This is the output that we get. So we can see, all right, first Sentinel runs, it contains information. Yep. Then it goes over to Knowledge Master. So Knowledge Master is going to have a bunch of tool calls in it. But we just printed those out so we can see and skip to what the tool calls were. But we have one of family consists of 6 people is the piece of knowledge. That's a family attribute and we're creating it. Wife doesn't eat meat. That's a food dislike. We're creating that. Youngest daughter is allergic to dairy. That's a food allergy, and we're going to create that as well. So we can go back over to LangGraph and see that run. Here's the initial call for Sentinel. You can see it doesn't have a whole lot of information in here. There's no long-term memories or anything that we're passing in. We're just trying to get back from this piece of information true or false. So boom, true. So now we know we continue to knowledge master. We've got a longer prompt here. It also has potentially the existing bits of information, none here. This is starting from scratch. So given this same piece of information, what are your outputs? It has the 3 tool calls. Each of these I'm going to do different database requests depending on what the action is going to be. So here we're just creating 3 new bits of knowledge with those attributes. And each of these now is being triggered, and I just kind of returned modified knowledge as a success state for each of these. So all of that is in GitHub. You can play around with it. Putting it into a UI then, this, I just gave it a database here. So this is going to be kind of streaming data back from a GraphQL endpoint. And we can see again, I just wiped it so it's got no information. So I have a daughter who cannot eat dairy. And we'll see in action. This is always kind of yep, daughter cannot eat dairy. My wife doesn't eat red meat. There we go. So that's kind of an interesting, that's a dislike versus an allergy. The reason I made the categories, I don't know if I talked through this, but this would just allow you to kind of chunk up all the memories and to kind of take different actions and prompts. Allergies, never ignore these. Likes and dislikes, these are good to know, but not like the most important critical piece of information. But yeah, it was pretty easy to kind of implement the memory thing. I think this is going to be really interesting to work with. And as I talked earlier, like there's a lot of different ways that you could actually start optimizing this. I think putting the memories into some sort of vector store or something where you can just start kind of like getting the relevant ones. Not every message that you have basically needs to have it. It may be that you always need to extract all of the allergies, so those are there, but the likes and dislikes don't need to actually be there. I'm not sure. It really depends on the different agent. As the meal planning agent, maybe it needs to know all that information, but probably can have different agents, and some of them need certain memories and not all of the memories. So I think there's a lot of ways to optimize that. There's also going to be a lot of different ways to consider how to actually track these messages. If you want all of them to persist, come back similar to how ChatGPT has a message log, then you're going to need to figure out a way also to implement how those messages are stored. And the way you store that is going to probably change how you trigger these different agents. Um, and then over here, adding these kind of sequential steps. This was, I think, just kind of a hacky, easy way to implement it. This is certainly going to add a little bit of a delay step. Condensing it into one is going to be great. Another option is, you know, maybe some of these memories are served from kind of like short term or long term, or if they're maybe the last 10 messages are all kind of sent through in this recent messages, so it has that information. You may only need to run this every time you want to condense that message log. Or if you're kind of caching these or storing them in the database, maybe you only actually save these memories at the end of a user session. So there's going to be different ways to optimize it. The question is, how do you get them into that short-term memory at least? So as long as they're in the recent message queue, you don't really need to be saving them perfectly. But the moment they leave that short-term memory queue or you're starting a new session, like you will have to have gone through and extracted all of them. So I think running it at every message is going to be something that's the first thing I would probably end up removing. Um, and then there's probably other considerations about, speed is not as important here because it's kind of just running in the background. So I don't need to optimize for speed here, but I do need to optimize probably for cost. So that's going to be the consideration, cost and accuracy. You definitely want to save an allergy correctly. So there's some different ways that you could approach kind of the optimization here for the memory agent, but for this implementation and with not many users, it can just run with every message. In the future, that's going to be the first thing that you've got to get rid of is how do you kind of batch that or only do that at the end of sessions or whatever it is. So there's going to be a lot of ways to kind of play around with that. But otherwise, getting it in here, I think this is already kind of immediately useful. Um, and I'm excited to kind of keep playing around with these long-term memories. Thanks for watching. Go to GitHub if you want to access the code, and see you later.